Good evening, everyone. So welcome to my YouTube channel. So today we are going to see a question, important question. Let G be an abelian group, non-abelian group. Okay. Then so that the mapping F G to G such that Fx goes to X inverse is not an automorphism. Okay. So for a non-abelian group, Fx is equal to X inverse is not an automorphism. Okay. How will show that? Let's see its solution. G is non-abelian. Implies there exists AB belongs to G such that AB not equal to B. Okay. So this implies taking inverse both these sides will imply. So what is this? This is B inverse A inverse, and what is this? A inverse B inverse. Okay. 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 Now, what is FAB? This is nothing but AB inverse. And AB inverse is B inverse A inverse. But because AB is not equal to B, I am taking both this side AB inverse. So this will not be equal. This will not be equal. That's one. Okay. Now, what is it? So from 1, this is not equal to A inverse B inverse. But A inverse is both F and what is B inverse what is FB. So this implies FAB equal to FA FB. This implies FAB is not equal to FB. Okay. So what is the meaning of this? So F cannot be homomorphism. If F is homomorphism, for homomorphism, FAB is equal to always FA into FB. So what does it mean? It means F is not homomorphic. This implies F is not homomorphic. We know that automorphism is always homomorphic. So this implies F is not homomorphic. Sorry, not automorphic. Okay. So this is true. So today's question after this, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's question. Thank you very much.